Unit 5, Objective 3 introduces us to a method of graphing data called the modified box plot. In example number 1, the data represents the test scores from 20 students who recently took an economics midterm. And here are their 20 scores. You notice they are already ordered from low to high. You're going to want to do that. If the data isn't already in order, you're going to want to do that. Now, the first thing we do on this data is we find the median. The median is the middle piece of data. Now, there are a couple of ways of doing it. You can just start with your fingers at each end and just start working your way in. That works. Or you can follow a little formula. In this case, there were 20 pieces of data. So you can take the number of pieces of data plus 1 and then divide by 2. So 21 divided by 2 is 10.5. Now what this tells you, that is not the median. That's where you can find the median. It's between the 10th and 11th piece of data. So that's where you're going to find the median. So let's find it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's the 10th piece of data. Here's the 11th piece of data. The median is between those two pieces of data. Now, what you would normally do is you would average each piece of data that's on either side of the median, but since they're both 91, 91 plus 91 divided by 2 is 91. So what we just figured out was the median is 91. Now, there's a couple of other things. The lowest is a really easy number to see. It's 59, the lower boundary. The upper boundary, or the highest number, is also easy to see. It's 104. Now, the first quartile and the third quartile, those are ones where it's probably just going to be easiest to use your fingers to find the location. Here's the lower half of the data, beginning with the number 59 and ending with this 91 right here. So let's find the middle of that data. Just work your way in, work your way in, work your way in, work your way in, and again we find the middle of that lower half to be right here. So it's between 77 and 78, so it's 77.5. That's the first quartile. Now, we're going to do the exact same thing for the upper half of the data. We're going to start with this 91 right here and 104, and we're going to work our way in. And we're going to find that the median is between these two numbers. And what's between 94 and 95? Well, 94.5, 94.5. So that's what we call our 5-number summary. The next thing we do is we check for outliers in the data. Are any of these numbers statistically unusually high or unusually low? There's a method for checking for outliers, and here it is right here. You take the third quartile, which in this case is 94.5, and you subtract the first quartile, which is 77.5, and you get a number. And then you multiply that number by 1.5. And then you get your new product. And that product in this case is 25.5. Now let's back up a little bit. There's actually a name for Q3 minus Q1. Q3 minus Q1 is called the interquartile range, or the IQR. So really, the first step in checking for outliers is you multiply the IQR by 1.5. Now, the next thing we do is we build our fences. And what we do is we take Q3, which in this case is 94.5, and we add this number, 25.5. And in this case, the sum is 120. And you also build your lower fence, which means you start with Q1, 77.5, and you subtract 25.5. And in this case, you get 52. Now, these are called our fences. This is the upper fence, and this is the lower fence. Now, these are somewhat like boundaries. Now that we found that our upper fence is 120, we go back to the data. Is there any data point larger than 120? And the answer is no. On the lower side, is there any data point lower than 52? And the answer is no. Since we haven't found any unusually high or unusually low numbers, we say there are no outliers in the data. And that makes building the box and whisker plot, the modified box plot, really easy, because all we do is we use the 5 numbers that are in the 5 number summary. The lowest was 59, so we put a dot right here where we think 59 should be. 77.5 is the first quartile, so there's 75, so let's go a little bit to the right of that and call that 77.5. The median is 91, so let's just go to a little bit to the right of 91. The third quartile is 94.5, which is almost to 95, but not quite. Now, we'll take those 3 lines and we'll make our box. And we'll also put our dot up here at 104, which is the highest number. There's 105, so back it off just a little bit, and there's 104. And we'll make our whiskers right here. And there's our box plot. It didn't have any outliers, so no outliers were shown because there weren't any outliers. Now, the last question on this, I added one more question down here, and that question was, if the highest score were removed from the data set, how would the standard deviation be affected? So there's the highest score right there, 104. If that test score never happened, what would that do to the standard deviation of this data? Well, the answer is it would decrease it, because the data would not be as spread out as it is right now. So here's the question right there. If the highest score were removed from the data set, how would the standard deviation be affected? It would decrease because the data would be less spread out. Example number 2 looks a whole lot like example number 1, but there are some very key differences in the 2 examples. The first one is, in example number 2, I'm dealing with 13 data points, which is an odd number, whereas in example number 1, we were dealing with 20 data points, which is an even number. Now, that doesn't sound like that big of a deal, but it really is. It makes a big difference in a couple of things, whether the data set contains an even amount or an odd amount of numbers. So, in example number 2, the 13 boys on the varsity water polo team practiced a shooting drill. In a fixed amount of time, each player took shots on a goalie. The number of goals scored is recorded below. So here's the results from the 13 players as they were doing that drill. And again, we're asked to find the 5-number summary. Well, we begin with the median, just like before, and you could do it one of 2 ways. You could work your way in from the 2 outsides to the middle, or you could do it by following the n plus 1 divided by 2. There were 13 boys, so there are 13 data points. So if we go 13 plus 1 divided by 2, That's 14 over 2, which is 7. Now remember, that doesn't mean the median is 7, but it can be found in the 7th position. Now, that's one of the big differences between this example and the other example. The median is one of the data points. 1, 2, 3, 4, 5, 6, 7. Right here. It isn't found between two of the data points. It's actually one of the data points. So, that's the median. That's 10 right there. The median is 10. Now, we can put in the low. We know the lower boundary is 7. We know the upper boundary is 31, the high number. And it's pretty easy to get the first quartile and the third quartile. Just look at the lower half of the data. Now, don't include the median. Just look at the lower half of the data and work your way in. And you find that the first quartile is found between these two numbers. And since they're 8 and 9, they are 8.5. And up here, if you work your way in, the third quartile is found between those two numbers. But since both of those numbers are the same number, then what that really means is the third quartile is simply 17. Now, let's check for outliers. Remember, an outlier would be either a statistically unusual high number or a statistically unusual low number. So, the procedure is the same. Start with the interquartile range. Remember, this has a name. Q3 minus Q1 is the interquartile range. So we're going to take 17 and we're going to subtract 8.5. And then we're going to multiply that by 1.5. And we get 12.75. Now, that's an important number in the next step, which is building your fences. So in this case, we're going to take the third quartile, which is 17, and we're going to add that 12.75, and we're going to get 29.75. That's what we call the high fence. Now we're going to take Q1, which is 8.5, and we're going to subtract that same number, 12.75. And that actually gives us a negative number, negative 4.25, and that's going to be our low fence. Now, we use those fences to determine if anything is unusual. Is there any piece of data that is above the 29.75 fence? And there is, that 31. What that tells us is the 31 is an outlier. Now, on the other side, there obviously isn't a piece of data that is below negative 4.25. So there are no low outliers. Now, that information is going to help us start building the box and whisker plot. If I push down just a little, here we go. Remember, we said there was no low outlier. So my lowest point is 7, so I'm going to mark that 7. My first quartile is 8.5, so that isn't going to be very far from the 7. My median is 10, which isn't very far from that. My third quartile is 17, which is just about halfway between the 15 and the 20. So let's stop there for a second. Let's build the box from those 3 lines. And this line goes down here. But this one's going to be a little bit different. Remember, we found that 31 was an outlier. That is an outlier. So we have to show it as an outlier. It gets its own special little showing. And the line does not go all the way up to an outlier. The line stops at the highest data point, which is not an outlier. So since that was an outlier, we stop the line at 19, which is right there. And that's what we call the modified box and whisker plot. And there is an outlier in the data. We've mathematically shown that there is an outlier. And here's how we show it on the graph. Now, there's one final question on this one, and that would be, if we hadn't seen the actual data up here, if we were just told the 5-number summary and the number of numbers, how would we know that 10 is an actual data point within the data set? Well, remember at the beginning of example 2, I told you there were some subtle changes. This one happened to have n equals 13 data points. So when we took that 13 and added 1 and then divided by 2, and we went 14 divided by 2 was 7, that tells us specifically that the 7th data point is the median. Whereas on the previous example, we had 20 data points. 20 plus 1 is 21. 21 divided by 2 is 10.5. That tells us that the median can be found between 2 other data points. So when n plus 1 divided by 2 is an integer, like this one was, you know for a fact that the median is whatever value is in that position.